Hello, everyone. Welcome to the Math Magician's Den. We are here again today working on limits. And this time we're going to work on limits that involve rational expressions, but they also involve radicals. What am I going to do if I have a radical in a problem and I plug in my number? Now, obviously, radical functions are continuous from 0 to infinity. So if I plug in 1, I should be able to figure out what it equals. Same thing with the bottom. It's a polynomial. I should be able to plug in 1 and see what it equals. Well, in this case, on the top, I get 1 minus 1, which is 0. On the bottom, I get 1 minus 1, which is 0. And again, this is called an indeterminate form. Indeterminate forms mean I cannot determine the limit the way it's written. I have to figure out another way to do this. Now, what we do, this is a method called rationalization. When you're rationalizing a problem, what you're going to do is you're going to take the radical expression, which is this one right here, radical x minus 1, and we are going to multiply by its conjugate. Conjugates are this. If you have a minus b, its conjugate is a plus b, and vice versa. And when you multiply those out, you get a squared minus b squared. So this is a real quick little method that we're going to use on this problem. We're going to multiply by radical x plus 1. I have a radical minus 1. I'm going to multiply by a radical plus 1. Now, the other trick to this is also making sure that you don't multiply anything that is not conjugates. So don't multiply the bottom out. And I'll show you the reason for that in a minute. I'm going to leave the bottom as x minus 1 times radical x plus 1. Don't multiply that out. And the great thing about the top is you don't have to multiply everything. You just multiply the first terms, which gives me x. You multiply the last terms, which gives me minus 1. Now, I'm hoping that all of you can see right now why I didn't have you simplify the bottom. Right there, when you cancel out that x minus 1 over x minus 1, that is the 0 over 0 that was complicating the question. And what I'm left with on the top is 1. And on the bottom, I can now plug in 1. So it'd be radical 1 plus 1. So the limit here is actually 1/2. This is called rationalization. Now, there is another method I could have used here. I could have taken this limit and thought of it as, well, maybe I can factor and cancel because the top is radical x minus 1, and you could literally think of the bottom as a difference of squares. It's radical x times radical x to get x, and then it's minus 1 and plus 1 to get the negative 1. And look at this. I can cancel out again radical x minus 1s, and that is the 0 over 0. So now I'm left with 1 on the top. I can plug the number into the bottom, and look at that. That also gives me 1/2. So this method of rationalization works on this problem, but factoring and canceling also works on this problem. Now, not every problem involves two methods that you can use. The next one, if I plug in 1, I hope all of you can see this. If I plug 1 into the top, I'm going to get 0. If I plug 1 into the bottom, 10 minus 1 is 9. The square root of 9 is 3. 3 minus 3 is 0. Well, darn it. I've got a 0 over 0 problem again. So what am I going to do to work this problem out? I am essentially going to take the radical expression, and I'm going to multiply this right here by its conjugate. I have a radical minus 3. So what I'm going to do is I'm going to put a radical plus 3. Don't change the radical. It is still radical x minus, or 10 minus x, but it's radical minus 3, so its conjugate is radical plus 3. Now again, one of the tricks to this is saying to yourself, hey, I got to remember, don't multiply out anything that's not conjugates. So the x minus 1 on the top, and that radical 10 minus x plus 3 on the top, we're not going to multiply that out. We are going to multiply out the bottom, though. Multiply the first terms. Radical times radical gives me what's under the radical, 10 minus x. Negative 3 times positive 3 That's negative 9. And what we're going to do is we're going to simplify this a little bit on the bottom so we can see what happens next. On the top, I still have the limit as x approaches 1. I've still got x minus 1 on the top. I've still got that radical expression, 10 minus x, then the plus 3. And on the bottom, if I simplify, 10 minus 9 is 1. So on the bottom, I get 1 minus x. And you're probably thinking to yourself, man, nothing really cancels there. Or does it? This expression right here, all I've done is change the signs from this expression right here. Those two expressions are opposites. I've got x, the bottom has minus x. The top has minus 1, the bottom has 1. When you cancel out these two factors, since they're opposites, it's going to leave me with a negative 1. So now I can plug in my numbers because this right here that I canceled in the blue, that is essentially your 0 over 0. That's what we're trying to do on all of these problems. We're trying to cancel out that factor or that expression that gives me 0 over 0. So let's plug in 1. I would get radical 10 minus 1 plus 3 over negative 1. Well, 10 minus 1 is 9. Square root of 9 is 3. 3 plus 3 on the top divided by negative 1. It looks like this problem gives me negative 6 for my limit. A little bit of work. Now, feel free to pause this video at any time and try some of these questions on your own. But I'm going to tell you right now, this problem, if I plug in 4, I'd get 16 plus 20, that's 36. The square root of 36 is 6. 6 minus 6 on the top is 0. If I plug in 4 on the bottom, I get 16 minus 16, which is 0. This is, again, an indeterminate form, 0 over 0. And there's other indeterminate forms, but this one is 0 over 0. So we're going to use this conjugate method again. We're going to multiply by the conjugate of the radical expression. I have 6 minus radical. So I'm going to multiply top and bottom by 6 plus radical. X squared plus 20. Now again, just ask yourself, am I going to multiply out the top or the bottom or both? Well, remember, in these problems, you do not want to multiply things that are not conjugates. So on the bottom, I'm going to leave it as x squared minus 16 times the 6 plus radical x squared plus 20. But the top I'm going to multiply out, and this is where we've got to be careful. And let me show you why we have to be careful. If you multiply the first terms on the top, that's easy. We get 36. If you multiply the last terms on the bottom, you get x squared plus 20. But remember the formula I showed you at the beginning. The result is supposed to be a squared minus b squared. You have to subtract that entire second expression. Hope you see what I did. We have to take the first square minus the last square. Now, if we do some simplifying here, the limit as x approaches 4. Again, the bottom is not going to change for now. It's x squared minus 16 times that conjugate we multiplied by, 6 plus radical x squared plus 20. On the top, I've got a negative x squared, and 36 minus 20 is positive 16. Now again, do you see it here? This expression and this expression. If you plug in 4 to both of those, you're going to get 0 over 0. But notice they're opposites. When we cancel out both of those, I'm going to get a negative 1. Now let's plug 4 into the bottom. 6 plus radical. 4 squared is 16 plus 20. That's 36. The square root of 36 is 6. This comes out to be negative 1/12. So notice indeterminate forms, all of these on this entire page so far have been 0 over 0. Now, honestly, I like to throw this problem in because it's kind of a tricky question. You have a radical on the top, radical on the bottom. In fact, we have 2 radicals on the top, 2 radicals on the bottom. What do we do? Well, if you multiply by the conjugate on the top, you're going to have craziness on the bottom. If you multiply by the conjugate on the bottom, you're going to have craziness on the top. But wait a minute. I thought I was supposed to plug in the numbers first. If I plug in 2 here, I get the square root of 2 plus 2, which is 4. If I plug in 2 here, I get 6 minus 2. I get the square root of 4, which is 2. This would be 2 minus 2. The top comes out to be 0. But if I plug 2 in the bottom, this would be 10 minus 1. That's the square root of 9, which is 3. Plus, this one, if I plug in 2, I get the square root of 9, which is 3. But it's 3 plus 3. What is 0 over 6? That's not indeterminate. It's just 0 divided by 6, which is 0. So always make sure that you don't have an indeterminate form first. You might just have a problem where plugging in the number is enough to find your limit. If you enjoyed this video, please hit the like button. And if you like the videos I've been posting, please subscribe to my channel. I'll be posting more videos as time goes by.